The topic here is the first derivative test to find extrema. So let's do this example. Let f of x equal x cubed minus 3 over 2 x squared minus 18x. So first we need to find the domain. It's a polynomial, so this is pretty easy. The domain is going to be all real numbers, right? You can plug in. The domain is the set of all axes such that f can take, and polynomials can take all the real numbers. Now we need to find the derivative. So f prime of x is equal, so that would be 3x squared minus 2 times 3 over 2x, 2 minus 1 is x, minus 18. Now to simplify, so this 2 goes with this 2. So this will be equal to 3x squared minus 3x minus 18. So that's the derivative. Now we need to find the interval on which f is increasing and decreasing. To do that, we need to find first the critical numbers. Critical numbers, we get them by setting the derivative equal to 0. So this means that 3x squared minus 3x minus 18 is equal to 0. Now we need to factor it. Factor 3, you'll get what? X squared minus x minus 6 is equal to 0. Factor that one also. This means that 3x squared minus x minus 6 product of negative 6. So it's x plus 2, x minus 3. So the critical numbers are negative 203. Now to find the intervals where f is increasing or decreasing, we put the critical numbers are here. So negative 2 on the left, then there is 0, and it's 3. So the domain goes from negative infinity to positive infinity. So we have all the x values, just the critical numbers. Now f prime of x, we put f prime of x here. F prime of x is, let's leave it, it's 3x squared minus 3x minus 18. So that's the derivative. So the derivative is equal to 0 here. It's equal to 0 here. It's equal to 0 here. Right? And this is f, so we're going to know where it's increasing, decreasing. So now I want to know where the derivative is positive or negative. So to check this interval, just plug in negative 3, any number between negative infinity and negative 2. So negative 3, for example, plug it into the derivative. So if we do f prime of negative 3, what will we get? Plug it in. So it's 3 negative 3 squared minus 3 negative 3 minus 18. And that's 18, and it's a positive number, therefore the derivative is positive there, which means the function is increasing on that interval from negative infinity to negative 2. Now between negative 2 and 0, pick any number. The easiest number will be 1. Plug it in into the derivative. F prime of 1 is 3, 1 squared minus 3 times 1 minus 18. That's equal negative 18, which is less than 0, so it's negative. Derivative is negative, means the function is decreasing. Now between 0 and 3, we got the easiest one will be, well, here we're supposed to plug in negative 1. Well, let's do f prime of 1 is less than 0, but 1 is here, right? So this is negative and this is decreasing, but let's plug in negative 1. So f prime of negative 1 is equal to 3 times negative 1 squared minus 3 times negative 1 minus 18, which is 3 plus 3, 6, minus 18, which is negative 12. Okay, it's also less than 0, so it's decreasing. It's less than 0. Now, all we need is f prime of we want to check this interval, so let's do f prime of 4. Plug in 4, we'll get 3, 4 squared, minus 3 times 4 minus 18, and this is equal to 18, positive, therefore it's positive here, and therefore it's increasing in there. So let's write the answer. So f is increasing on where? Right here, right? And right here. So from negative infinity to negative 2, union 3 to infinity. So this will be the answer. Now f is decreasing where? F is decreasing on from here to here, so negative 2 to 3. So this is the answer. That's what it's increasing and decreasing. Now we need to find the local maximum and minimum values. That's pretty easy. Wherever it's if you look here at x equal negative 2, it's increasing, then decreasing. Therefore, that's a max. So local max will be equal to f of negative 2. We're still going to have to evaluate it. And then at 0 there's nothing, and then at 3, see, it's decreasing then increasing, so we got local min at x equal 3, which is equal to f of 3. So all we need to do, plug in negative 2 into the original function. Original function is right here, so this will be negative 2 cubed minus 3 over 2 negative 2 squared minus 18 negative 2, which is equal to 22. So this is our local max. And then f of 3 is equal to 3 cubed minus 3 over 2 3 squared minus 18 times 3, which is equal to negative 81 over 2. So this is our local min. And that's it for this problem.